what is the price of each one, they worded that bad. What is the price of one senior citizen ticket and one student ticket? So guess what our two unknowns are. Price of a senior citizen ticket and the price of a student ticket. So if you look at the end of the question, that's usually where they're asking what they want you to find out. And that's what they're asking for is their unknown. Okay. So you can we need to label our variables. Do you want to use X and Y, or do you want to use like S for senior and T for student or something like that? X and Y. It doesn't matter. So this is going to be X. I'm going to say, okay, X is senior citizen ticket, Y is a student ticket. Or you can write it on the side, X equals senior citizen, Y equals student. So something that you can check back and reference real easy, real quick. You're like, okay, what was X, what was Y? If you don't use, you can use letters that represent those things as well. Okay, so that's usually the first thing. Skim through it, read it, find out what two things do they want us to find out, to figure out here. Now we're going to go back through and we're looking for totals. Okay, so we see $102 and it says for senior citizen, 5 student, for a total of $102. So if you sell 4 senior citizen tickets, and X is the amount of a senior citizen ticket, that's an S. Okay, that's going to be 4X plus 5Y equals 102. Because 102 was the total. 4X is how much money you'd get from senior citizen tickets. So if it costs $5 a ticket, you get $20. We don't know how much it costs yet, so we just put X. Okay, so 4X plus 5Y equals 102. Keep reading. The school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. That's not a lot of people in the stands. I guess you have adult tickets mixed in there too. So 7 senior citizens would be, how would you write that? So 7 senior citizen would be 7X plus 5Y equals 126. Does that make sense where all the numbers came from? Now there's several ways you can solve this. But using what we've just practiced, what could you multiply one of the equations by to eliminate the y's? Negative 1, because there's a positive 5 and negative 5. Okay, so now we're back to what we did last Thursday. Okay, so this is the only part that's new, is being able to write those equations. So now you have to solve it. If it was me, I'd take the top one times negative 1. If you haven't checked your school email, I did email you a link to the folder for our classroom videos. So I'm starting to record these more now that we're getting into a little bit newer stuff. So if you save that folder, you can go back and watch what we did in class. And it's just this screen and whatever it picks up of my voice mostly. So when I move around the classroom, sometimes it doesn't pick up as well. So it's not recording you. Someone have a value for X? X equals 8. That means Y equals 14. The rest of you agree? those are our x and y values. Now what's the answer to the question? So you have to make sure you answer the question now. It's what's the price of one senior citizen ticket? $8 student ticket. So we're going to say $8 for a senior citizen ticket, or $8 for a senior citizen, $14 for a student. Must be a good talent show. Okay. So your answers, don't write them as ordered pairs now. These are word problems. Make sure your answers answer the question that's in the problem. Now, before we move on, I want to look at this problem in trying to understand what's going on here. When you have the same number of student tickets, how much did the price go up when the senior citizen tickets increased by 3? How much did the price go up for 3 more senior citizen tickets? $24. So if 3 extra tickets cost $24, how much per ticket? 8. Isn't that what you did right here?
Yeah.
So you did the math, but I want you to be also thinking, okay, I'm selling the same number of student tickets, so that total should be the same. I'm selling 3 more senior citizen tickets. It went up $24. 24 divided by 3 gives you $8 senior citizen ticket. So a little bit of common sense trying to work its way in there as well. Remember, don't necessarily always want you just to be robots. I want you to be thinking about what these numbers represent. Okay, number 2. Unless there's questions on number 1. Okay, number 2. These are actually fairly simple. They sound confusing, but we're going to be flying with the wind. So a plane went 183 kilometers per hour. So we are making some assumptions here. First of all, we're assuming that the wind is right behind the plane, not crossways to the bus like it was on this weekend. Okay, that was fun. Hopefully it didn't rock around too much. Yeah. Look at some of those semis. Okay, anyway. So we're assuming that the wind is directly behind the plane. Sorry, it was windy when I was driving the bus up to Dodge City. So that means however fast the plane is going, the wind is pushing it that much further. So if the plane's going 200 miles an hour, the wind is blowing at 60 miles an hour, we're going to assume that the plane, in relative to the ground, is going 260. Okay, let's get back to that. Have you seen who's ridden a plane before? Okay, you have 2 things. You didn't take a boat over? Okay. You have, let me write this up here. This is kind of cool. This is kind of funny. When I was in college, I had opportunities to go overseas, went to Asia, Europe, different places. And when you're on those bigger planes, they have screens, and the screens say you have an airspeed, you have a ground speed, and then you have a wind speed. Now, the wind speed may not always be written on there. Okay. So an airspeed is how fast the plane is going in still air. So if there was not any wind at all. Okay. So can an airplane be going at 200 miles an hour, but on the ground it's only covering 180 miles per hour? Yeah. So if the wind is blowing against it, right, it's going to slow it down in relationship to the ground. It's not like a car that has contact with the ground. A car makes contact, so whatever you're going on the ground, that's what it's going to be. A plane, you're up here in the air. Okay, so if the wind is affecting the airplane. So if it's going 200 miles an hour, that means if you stick your hand out, it would feel like 200 miles an hour because the wind going against your hand, you may not have a hand anymore. The wind going against your hand feels like 200 miles an hour. But if that wind is pushing against the plane, it's going to slow the plane down in relationship to the ground. Okay? Does that make sense? So if you're going against the wind, it's going to slow you down. If the wind is behind you, it's going to speed you up. Okay? So the ground speed equals airspeed plus or minus wind speed. So it's plus wind speed if you are going with the wind, and it's minus airspeed if it's going against it. Now what gets cool is what happens when it's coming at an angle against you. Okay? So then you get to do some trigonometry and figure some stuff out as far as, okay, if I want to fly to Newton, but the wind is coming from the east, that wind is going to push me to the right, so what direction? I might be flying this direction, I might be facing this direction, but my plane's going this direction. That's vectors. That's fun stuff. That's pretty cool. We're not going to, unfortunately, get there. Take pre-calc for that, advanced math. Okay. Oops. Yeah. So if you have a strong enough wind, you may have to fly north for it to push you. That's not possible.
20 miles per hour.
Okay. So notice these are speeds, ground speed. So what kind of labels do we have for speed? Miles per hour, kilometers per hour. So ground speed equals airspeed plus or minus wind speed. Alright, long story short, let's look at this. Flying with the wind, a plane went 183 kilometers per hour. So is that a speed? Okay. Now this is a ground speed. So when they give you this rate right here, they're giving you a ground speed. So if you're flying with the wind, remember airspeed plus wind speed equals the ground speed. So if you're flying with the wind, is it pushing you or fighting against you? Pushing you. The wind's from behind, so it's pushing you. So airspeed plus wind speed equals 183. That's all you have to do for the first one. Airspeed plus wind speed equals ground speed. That 183 is the ground speed. That's in relationship to the ground. Okay. Flying into the same wind, the plane only went 141 kilometers per hour. So what's that 141 represent? It's another ground speed. So what's happening this first time, the wind is behind us and it's pushing us, right? Well, super fast. Now we turn around, we land, we turn around, now we're going back home. Now we're flying against that same wind. It's a different situation. So it's a different equation. So if you're flying into the same wind, the plane only went 141, so now is it airspeed plus wind speed or airspeed minus wind speed?
Airspeed minus.
Okay, so airspeed minus wind speed equals 141. Okay, guess what? Set up. That's all you have to do with that. We just have to solve it. Now look at your wind speeds. What happens there? Cancel off. So you're ready to add these together. What's A plus A? 2A. Most common mistake? Huh? Okay. Equals 324. Most common mistake is people will just put A equals and not 2A equals. Okay. So 324 divided by 2 would be 162. So airspeed equals 1.